The dark forest theory proposes that the universe teems with intelligent civilizations, but all remain silent because any species that reveals its location gets immediately destroyed by more advanced predators. Chinese author Liu Cixin popularized this concept, though physicists and astrobiologists have seriously explored its game theoretical validity. The logic follows: resources are finite, technological trajectories are unpredictable, and survival demands eliminating potential threats before they eliminate you. If true, SETI broadcasts and Voyager's golden records represent catastrophic mistakes, cosmic emergency flares advertising Earth's coordinates to whatever hunters patrol the darkness. Advanced civilizations would function as silent predators, listening for prey foolish enough to announce themselves. This theory explains the Fermi Paradox perfectly, while suggesting that cosmic silence is not absence, but restraint. The mathematics of survival in a resource-competitive universe support this paranoid model. Our radio signals have already propagated across 120 light-years of space, potentially marking humanity for annihilation. The most unsettling aspect is that proving the theory correct means experiencing it. First contact becomes last contact. No current observations can definitively confirm or refute this hypothesis, leaving it in the realm of rational speculation that keeps some astronomers awake contemplating our broadcasts. Next, we have the Fermi Paradox. The Fermi Paradox questions why, in a universe containing billions of galaxies with billions of stars each, we detect zero evidence of extraterrestrial civilizations despite statistical probability suggesting thousands should exist in our galaxy alone. Physicist Enrico Fermi crystallized this contradiction in 1950 with the simple question, where is everybody? The Drake equation mathematically demonstrates that even conservative estimates predict numerous detectable civilizations, yet our most sensitive instruments find only silence. This paradox has spawned hundreds of proposed solutions, from the rare Earth hypothesis to technological self-destruction scenarios. For humanity, it suggests either we are cosmically alone, a statistical impossibility that places unbearable significance on our survival, or something prevents civilizations from becoming detectable. The disturbing element lies in the great filter interpretation. Perhaps intelligence inevitably destroys itself before achieving interstellar communication, meaning our own extinction approaches. Radio telescope surveys covering millions of star systems have yielded nothing, strengthening the paradox rather than resolving it. Every year without detection makes the silence more statistically improbable and more philosophically troubling. This remains one of astrobiology's central unsolved questions, with implications ranging from loneliness to impending doom. Moving on to the zoo hypothesis. The zoo hypothesis suggests advanced extraterrestrial civilizations know Earth exists, but deliberately avoid contact, observing humanity as we observe wildlife in nature preserves without interference. Astronomer John Ball formalized this concept in 1973, proposing that galactic civilization might enforce non-intervention policies until species reach specific developmental thresholds. The reasoning assumes sufficiently advanced aliens possess complete awareness of all developing civilizations and coordinate to prevent contamination of natural evolutionary processes. For humanity, this means we exist inside a cosmic enclosure, our apparent isolation artificially maintained by entities watching from beyond detection range. The unsettling aspect combines infantilization, we are considered too primitive for contact, with surveillance, suggesting our entire history unfolds under alien observation. Some interpretations propose we are deliberately quarantined, due to dangerous tendencies like violence or irrationality. This hypothesis requires assuming aliens think like conservationists rather than conquerors, which itself represents anthropomorphic speculation. No evidence supports this theory beyond absence of evidence for alternatives. It remains philosophically interesting but empirically untestable, representing more thought experiment than scientific hypothesis. The theory persists because it is unfalsifiable and provides psychological comfort. We are alone because they choose to let us be alone. Up next, the Great Filter. The Great Filter proposes that some evolutionary bottleneck exists between simple life and galaxy-spanning civilizations, so difficult to pass that it explains why we observe no evidence of advanced aliens despite billions of years for them to emerge. Economist Robin Hanson developed this framework in 1996, identifying that the filter could lie behind us, meaning we have survived the impossibly Difficult step or ahead of us, meaning extinction awaits. Statistical analysis of the universe's age, star formation history, and planetary abundance suggests thousands of civilizations should precede us by millions of years, yet none appear detectable. For humanity, a filter ahead means civilizations routinely destroy themselves through nuclear war, environmental collapse, artificial intelligence, nanotechnology, or technologies we have not invented yet. The disturbing conclusion, our apparent uniqueness might signal not our specialness, but our proximity to universal self-annihilation. Every technological advancement without catastrophe either proves the filter lies behind us or brings us closer to it. The filter could be a biogenesis, multicellular life, intelligence, technology, or something that occurs after radio capability. Climate change, nuclear arsenals, and AI development provide contemporary candidates for humanity's potential filtering event. This remains actively debated in astrobiology and existential risk research, with no consensus on filter location or nature. Next up, simulation theory. Simulation theory posits that our reality represents a sophisticated computer simulation created by advanced beings, making everything we perceive, including the laws of physics, artificial constructs rather than fundamental reality. Philosopher Nick Bostrom formalized the simulation argument in 2003, demonstrating that if post-human civilizations run ancestor simulations, statistically we almost certainly exist inside one. The reasoning: future civilizations might run billions of simulations, meaning simulated consciousnesses vastly outnumber real ones, making simulation membership probabilistically overwhelming. Quantum mechanics exhibits computational properties like discrete quantization and the observer effect that resembles simulation rendering optimization. For humanity, this suggests our universe, history, and consciousness might be programmed, entertainment or research for entities beyond comprehension. The unsettling element combines existential insignificance. We are video game characters with determinism, as our reality could be paused, edited, or terminated arbitrarily. Some physicists propose the simulation hypothesis makes testable predictions about Planck-scale physics and information processing limits. No definitive evidence confirms simulation, but no evidence conclusively refutes it either. This remains philosophical speculation that occasionally intersects with quantum physics interpretations. The theory's persistence reflects how successfully it exploits unfalsifiable reasoning while remaining technically plausible given technological trajectories. Moving on to false vacuum decay. False vacuum decay theory warns that our universe might exist in a metastable quantum state that could spontaneously collapse to a lower energy true vacuum, fundamentally rewriting physics and obliterating everything in an expanding bubble traveling at light speed. Quantum field theory demonstrates that vacuum states possess energy levels, and systems naturally seek lowest energy configurations through quantum tunneling. Current measurements of the Higgs boson mass place our universe uncomfortably near the boundary between stability and metastability, suggesting we inhabit a false vacuum sustained only temporarily. The collapse would begin randomly at a quantum point, then propagate outward as a sphere of altered physics where matter, energy, and physical laws cease functioning as they currently do. For humanity, this represents unpredictable, unavoidable annihilation. We would not see it coming because the destruction front travels at light speed, erasing everything instantly without warning. The disturbing element is complete helplessness. No technology could prevent it, detect it, or escape it. Calculations suggest this might not occur for billions or trillions of years, or it could begin in the next second. The universe's continued existence for 13.8 billion years provides some statistical comfort but no guarantee. This remains speculative but mathematically consistent with quantum field theory and standard model physics. Scientists rarely discuss this publicly because it combines absolute catastrophe with absolute unpredictability, creating existential dread without actionable response. Next, we have heat death of the universe. Heat death describes the universe's inevitable thermodynamic end state, when entropy reaches maximum, energy gradients disappear, and no work becomes possible, leaving only uniform temperature equilibrium in eternal darkness. The second law of thermodynamics guarantees entropy always increases in closed systems, meaning the universe progresses irreversibly toward disorder and thermal equilibrium. Current observations of cosmic expansion and dark energy suggests this process will culminate in approximately 10 to the 100th power years, when the last stars extinguish and black holes evaporate. All structure, galaxies, stars, atoms will decompose into diffuse radiation at near absolute zero temperature. For humanity, this represents cosmological nihilism. Everything we build, discover, or create becomes ultimately meaningless against infinite time erasing all traces. The unsettling element combines inevitability with timescale incomprehensibility, not sudden catastrophe, but slow, inexorable decay into nothingness. No physical law permits reversing entropy or escaping heat death. It represents thermodynamic destiny. Proton decay, black hole evaporation via Hawking radiation, and quantum fluctuations will dominate the final eras. This remains the most scientifically certain universal fate according to current physics understanding. Scientists discuss this academically, but avoid emphasizing how it renders all human achievement cosmically temporary, preserving motivational narratives despite thermodynamic futility. Up next, Boltzmann Brain theory. Boltzmann Brain theory proposes that in an eternally existing universe, random quantum fluctuations will spontaneously generate conscious observers, including you right now, more frequently than entire evolutionary histories, making it statistically more likely you're a momentary brain fluctuation, experiencing false memories than an actual person. Physicist Ludwig Boltzmann explored this paradox regarding entropy and cosmological time, revealing how probability behaves across infinite duration. In heat death's maximum entropy state, quantum fluctuations occasionally produce ordered structures, and a single disembodied brain with false memories requires vastly less improbable fluctuation than an entire consistent universe. For humanity, this means our memories, relationships, and reality might be phantoms. You could be a brain flickering into existence this instant with implanted false history, only to dissipate next moment. The disturbing element is unfalsifiability. No observation distinguishes genuine existence from Boltzmann brain delusion, because the delusion includes all evidence you would use to verify reality. This creates a reductio ad absurdum argument, used to challenge certain cosmological models. If a cosmology predicts observers are more likely Boltzmann brains than evolved beings, the model becomes problematic. This remains a theoretical physics puzzle rather than mainstream scientific concern. The theory persists because it reveals how probability and infinity create paradoxes that undermine certainty about our own existence. Moving on to time loop cosmology. Time loop cosmology suggests the universe might be cyclical or closed such that time curves back on itself, meaning the Big Bang and heat death are the same event, or that causality forms loops where effects can precede causes. Some solutions to Einstein's general relativity equations permit closed time-like curves where world lines circle back to earlier points. The universe's global topology remains unknown. It could be closed like a sphere, making time itself circular. For humanity, this means history might repeat eternally, or our future selves could influence our past, or causality itself is an illusion created by local time perception. The unsettling element is deterministic imprisonment. If time loops, free will becomes meaningless, as all events are predetermined by their own future consequences in an endless cycle. Quantum mechanics and general relativity produce mathematical frameworks, allowing time loops but create paradoxes like the grandfather problem. No observational evidence confirms or refutes time loop cosmology. This remains speculative physics exploring extreme implications of relativity theory. Scientists hesitate discussing this publicly because it challenges fundamental assumptions about causality, progress, and temporal flow that underpin how humans conceptualize existence. Finally, self-replicating alien probes. The self-replicating probe hypothesis suggests that advanced civilizations might explore the galaxy through autonomous spacecraft that travel to star systems, create copies of themselves from local materials, then send those copies to new destinations in exponential expansion. Mathematician John von Neumann proved such self-replicating machines are theoretically possible. An astrophysicist calculated a single probe could colonize the entire Milky Way in 1 to 10 million years, brief on cosmic timescales. If any civilization ever created such probes, millions should now permeate our galaxy, making their absence another disturbing variant of the Fermi Paradox. For humanity, this suggests either we are first to conceive this strategy, statistically unlikely, or something destroyed all previous probe networks. The unsettling element: these probes might already exist in our solar system, dormant until detecting technological civilization or functioning as surveillance, equipment reporting our development to distant creators. Some theorize certain asteroids or comets could actually be ancient dormant probes. The Oumuamua interstellar object exhibited anomalous acceleration, some interpreted as potential evidence, though natural explanations remain more probable. No confirmed observations exist, but absence of evidence is not evidence of absence. This remains speculative astrobiology intersecting with xenoarchaeology concepts. The theory disturbs because it combines surveillance anxiety with the question of why we do not see them. Perhaps they are hiding, or perhaps they are waiting.